When we talk of cleanliness for a glove, we address two concerns, and these are the same concerns that we have with a wiper. What are the particles that come off the glove, and what are the extractables? To determine if there are particles, there's a couple of particle tests. One of them is you take a glove and you put it in a Helmke drum, which tumbles the glove with a particle counter, and you count the particles that come off the glove that's being tumbled versus the particles that come off when there's nothing being tumbled. The difference between the baseline and the count is the amount of particles that come off. That's called APC. APC for air particle count. Another common type of a particle count is the clap test. And the clap test is very common in Asia. And what they do by the clap test is they literally take gloves, as an operator would, they clap them and they rub them, and then they have a particle counter and they count the particles that fall off. Still an air particle count test. Another way to determine air particle counts is just to smell the glove, to see if the glove has an odor from it. If you take a latex glove and you take a latex glove and you snap it, 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 then you go to smell it, wow, it stinks. It's outgassing, right? Things in clean rooms shouldn't be outgassing. If you can smell an odor, there's actually molecular contamination that's being released from the glove into the environment, which goes back to what we talked about before, that latex isn't as clean as nitrile. And evidence of that is the outgassing. So let me explain how an LPC test is done, liquid particle count. The most common way we test our gloves is an air particle count. But if someone wanted to know a liquid particle count, what you would do is you would take a known quantity of 18 megaohm ultra pure water. This is very, very clean water. You would do a test on this water to see the amount of particles in that water and the chemical characterization, the extractables. Then you take this water and you put it in a vessel, and then you take, typically not a whole glove, although some clients have different specifications. The most common specification is to cut a uniform size out of the glove. But you would take the glove, okay, you would put the glove in this ultra pure water, and then you would put it in something called an orbital shaker. An orbital shaker. What we're doing is we are agitating the glove in the ultra pure water, right? So we're agitating it for, the typical test method is 10 minutes. The reason for this prolonged agitation is to try to enhance particles to be released from the glove, all right? Then you take the glove out of the ultra pure water. We're done with that, and then we do chemical analysis of this ultra pure water. The chemical analysis of this water is what we call LPC, liquid particle counting. We're going to count the number of particles that are in the water, and then we're going to analyze those particles to determine what elements they are. Are they silicone? Are they zinc? What are the specific elements? So it's the mimic test, the same test that's done with a wiper. You basically take ultra pure water, you prepare the sample, you soak the sample in the water, you remove the sample, and then you do analysis on this. The difference between the baseline analysis and the analysis after the material has been tested, that's what's going to give you the amount of particles and the amount of extractables. So that's how we determine cleanliness. So when somebody says, I want to know how clean the glove is, your next question should be, well, tell me a little bit about that. Are you interested in particles, or are you interested in extractables? And then when they say particles, they say, oh, well, how do you test for particles? Do you just do a clap test? Do you do a Helmke drum test? Are you basically just taking the glove and shaking it in the air to see what kind of particles come off it? Or are you doing a rigorous LPC, liquid particle count test? By this point, you're way over the buyer. The buyer's thinking, oh my gosh, I better put this value tech salesperson in touch with somebody that knows something about our glove cleanliness, because buyers, You start talking about particles and extractables and liquid particles and air particles, and you just lost them. But that's why we want to focus on this, because if you can get to the technical person to find out what they need, then we can offer the right glove. And then it's not so much a challenge that everybody isn't fitted with the glove, because we've addressed the cleanliness. The reason why it's of paramount importance that the glove is clean is because these gloves are not designed just to prevent the operator from getting infected or exposed to what they're coming in contact with. The primary purpose of this glove is to make sure, so envision that we're touching a $25,000 defibrillator, that if we come in direct contact with the product, that we don't contaminate it. So the technical people are very, very concerned about the cleanliness. They don't really care if the glove is comfortable. They just want to have assurance that if the operator touches things that they shouldn't, that they're not going to contaminate. Whereas the production supervisors, the purchasing people, they tend to be swayed by, hey, is it comfortable? Because they want it to be pleasant in the lunchroom, right? They don't want people coming up to them at the holiday party and saying, what are you doing? Why are you messing with me? Can't you at least order me a glove that's comfortable? Thank you.